Till now, you have learned digital read function. In this lesson, first I'll tell you what you can't do with digital read. To establish that, I have to build up a scenario. Then let me tell you first, there are two types of signals. One continuous and second is discrete. Continuous signals have multiple amplitudes over a course of time. But discrete signals have only two amplitudes over a course. See this image? This is a continuous signal. Now look at the time slots. T1 has an amplitude A1, T2 time slot has A2 and T3 has A3. These amplitudes are different, so they are voltage levels. Say this point is of 5 volt and this point is of 4 volt. I am telling you the amplitudes in voltages. Now digital read, which can read only two voltage levels, high and low, or you can say 5 volt or 0 volt, has a problem. If a pin detects 4 volt, then digital read will give you high. If the pin detects 5 volt, it will also give you high. There is a 1 volt difference, but digital read is unable to capture that. This particular problem has a solution. The solution is analog read or using of the ADC. Using analog read, we can read different voltage levels. In our case, that is Arduino Uno, the voltage levels can vary from 0 volt to 5 volt. So what ADC does is, it will give you values for each voltage it reads. Like if it reads 2 volt, the value can be 400. If it reads 3 volt, the value can be 600. So what is analog read? This analog read function is directly associated with the ADC, and ADC is a peripheral inside the microcontroller. If you don't know what ADC is, then let me tell you, ADC stands for analog to digital converter. ADC helps the microcontroller in reading continuous signals. How it reads? It reads the voltage level first, then converts the level into a value. The processor then processes the value accordingly. Many sensors sense a physical quantity and generates output in continuous signal format. These signals can be read using ADC. Some examples of these sensors are voltage sensor, current sensor, temperature sensor, pressure sensors, gas sensors, etc. Whenever you try something with ADC of a controller, then you must know these concepts like what is channel and what is resolution. So let's start with what is a channel. A channel refers to ADC inputs. Every ADC can read a number of signals. So how many signals depend on the number of channels. So channel is basically the number of analog inputs. In Arduino Uno, there are 6 analog inputs from A0 to A5. So there are 6 channels. I think this seems to you. Now come to resolution. To understand what is resolution, I'll give you an example. What is this? This is a 30 centimeter scale. If you look at this image carefully, you'll find that the minimum division in this scale is 1 mm. So there are clearly 300 divisions. Now, if I ask you a question that I have a 30 centimeter scale, Let me denote it as scale 1, which has 300 divisions. I have a separate scale of 30 centimeter. I have denoted that as scale 2. It has 3000 divisions. Now think, which scale is more precise? You can pause the video and think. The right answer is scale 2. Why? Let me explain. It's a simple math. In scale 1, if I divide the total length by the number of divisions, it becomes 300 by 300 in mm is equal to 1 mm. So using scale 1, we can measure a minimum length of 1 mm. Now come to scale 2. In scale 2, if I divide the total length by the number of divisions, then it becomes 300 divided by 3000. It becomes 0.1 mm. So using scale 2, we can measure a more precise length, that is 0.1 mm. So scale 2 has higher precision than scale 1. We can measure a smaller length than scale 1. If I put this example in context of Arduino Uno, then in ADC, the resolution decides the precision. How? The resolution tells you the minimum voltage an ADC can measure. In Arduino Uno, the controller Atmega 328P has a 10-bit ADC. So maximum divisions can be 2 to the power 10, that is 1024. That means the result of ADC conversion process is always a 10-bit value. So if I put all the bits as 1 in a 10-bit register, it will become 1023. You can check that in calculator. So 0 to 1023, this range is same as 1 to 1024. So the step size in both the cases is 1024. And what is the measurable range of Arduino ADC in terms of voltages? It is 0 to 5 volt. Now the step size is 1024, as I told you. So the minimum measurable voltage is 5 divided by 1024. It's almost 5 millivolt. So this ADC can detect a small 5 millivolt change in voltage level. Say if it reads a 5 volt, it will give you a result of 1023 after conversion. If it reads a 4 volt, it can give you say 800 after conversion. Let's take another example. If a controller has 12-bit ADC, what will happen then? Then the divisions will be 2 to the power 12 is equal to 4096. Then the whole calculation in this scenario becomes like the minimum measurable voltage is 5 divided by 4096. It is equal to 1.22 millivolt. Clearly you can see the more the bit specification an ADC has, the more precise it will be. So a 16-bit ADC is more precise than a 12-bit ADC. And this is called the resolution. And this is how it works. Now that is clear to you, I guess. Now let's get into the syntax. How we write analog read function? We write analog read R in capital within bracket parameter 1. This function is a return type function and it returns an integer value. So whenever you write analog read, you should mention a variable before, like int value is equal to analog read within bracket parameter 1. As parameter 1, we send the channel number and it can be any value between A0 to A5. It depends on where you have put your voltage input, or you can say where you have connected your voltage input. For this, I'll do a small experiment with potentiometer and read the voltage levels. Then print that in and then print it on serial monitor. Our circuit will be something like this. I have designed this in freezing. I have taken a potentiometer which has 3 pins. One will be connected to 5 volt, another, the leftmost pin, will be connected to ground, and the middle pin will be connected to my analog input A0. The pot looks like this. If I rotate the pot, the voltage level at the middle pin, which is connected to A0, will change, or you can say will vary. The range of voltages at A0 will vary from 0 volt to 5 volt. And this will be my methodology, and I'll read the voltage levels and analog read, and those values I'll print it on serial monitor. Let's make the connections then. So this is my setup. I have this potentiometer. This is a dust cap potentiometer. So there are 3 pins, and the middle pin is used for output, and there are 2 pins on the left and right side. So see this carefully. So now I have connected one potentiometer at the breadboard. The left pin is connected with this red wire, which will be connected to 5 volt according to the circuit. So let me connect that. Now the rightmost pin that is connected to this green wire, I will connect this to ground pin, and the blue wire will be connected to pin A0. The blue wire will have the variable voltage. Now let me connect the USB cable to upload my program. Let me open Arduino first. Close this update notification. Now I will define A0 pin as a pot pin. So I am giving a name, pot pin. So inside void setup, I'll initialize the baud rate as 9600 by writing serial.begin 9600. Now here I am defining a variable called value, which will store the return of function analog read. Analog read will eventually read the voltage levels of A0 and will store it in value. And here I am printing the value on serial monitor. By giving a delay, actually I am slowing up the printing process. Now let me save it. I am writing analog read. Let me save it as analog read. Now I'll check Arduino is at COM5. Let's upload. Done uploading. Now I'll open serial monitor and see the pot is at middle position. Now I'll rotate the potentiometer to its maximum. See, it is giving 1023. So here I am rotating the pot to its minimum, and now the value is decreasing, and it will come to 0. See, this is the minimum value, minimum voltage level. Now I am again increasing to its maximum. Now it is giving 1000. Now I'll reduce the value by rotating the potentiometer, and see, it is decreased to 0. This is how ADC works. Again I am rotating it to its maximum, and again rotating it, and set at middle position somewhere near to 512. In the next lesson, I'll discuss analog write.